All right, let's jump straight into this explainer and see exactly how we can filter the absolute chaos of organizational data into pristine, auditable truth. If you're working with artificial intelligence, you already know that managing these systems requires a staggering amount of oversight. So today, we're looking specifically at the ISO/ISE 42001-2023 standard, and we're going to explore how a lead auditor gathers objective, highly reliable evidence to actually prove compliance. So, here's the big question. How do you find the truth in an avalanche of AI data? Because let's face it, it's a very real catastrophe for most organizations. Imagine millions of lines of system logs, scattered chat messages, half-finished policy documents, and training records just spread across 10 different departments. That is the digital data avalanche. And an auditor, well, they can't just take your word for it that your AI is secure and ethical. They need precise, crystal clear truth. They need absolute proof. Now, to get that proof, we have to ground ourselves in a very specific concept: verifiable evidence. This means information collected during an audit that is factual, accurate, and crucially, capable of being independently verified. It might be documents, records, observations, or interviews, but the core idea is this. If another auditor walked into your office tomorrow, they could look at this exact same evidence and come to the exact same conclusion. It's literally the bedrock of the entire audit. Okay, here's our game plan. 1. Facing the data avalanche. 2. The 5 pillars of reliable evidence. 3. The auditor's essential toolkit. 4. Shielding data from critical risks. And 5. Building trust through verifiable truth. Starting off with Section 1, facing the data avalanche and why we desperately need reliable data. It's honestly like night and day when you look at the messy reality of raw organizational data versus the structured perfection required by an audit. Think about it. When an auditor evaluates a high-stakes AI system, say a machine learning model used in healthcare diagnostics or financial loan approvals, they can't just sift through a chaotic pile of raw logs and scattered sticky notes. If they base their findings on unverified or incomplete data, it leads to incorrect conclusions, which completely invalidates the whole audit. They have to transform that raw mess into structured, factual, and highly accurate verifiable evidence. Which brings us to Section 2. The 5 pillars of reliable evidence, or basically our filters. So how exactly do we filter that raw data and push it through the funnel? Well, we use a very strict checklist of filters to ensure our evidence is totally flawless. First up is accuracy. The data has to be precise, 0 transcription errors, no wrong timestamps. Second is relevance. If we're auditing financial controls, we only want evidence pertaining to that, right? Not marketing metrics. Third is sufficiency. We need an adequate sample size to form a well-rounded judgment. Fourth is consistency. The data absolutely must align across different departments and systems. And fifth, availability. The auditor needs to actually access this evidence within the audit timeframe. Put simply, if you can't find the logs, they don't count. Now here's a massive trap you've got to watch out for. Say your interviews with employees reveal they receive weekly data privacy training, but then your system logs show no one has logged into the training portal in 6 months. Your evidence just isn't strong enough yet. Inconsistent data will derail your audit every single time. A lead auditor has to cross-reference evidence from different sources to ensure absolute consistency and accuracy. Moving to Section 3, the auditor's essential toolkit for extracting the data. We know the theory, but what does an auditor actually do on the floor to pull this data into our funnel? Let's open up the toolkit and look at the real-world methods. First, there's document review. This is checking policies, system backups, and training records to make sure they are current and complete. Next, interviews. Actually sitting down with the staff to gather insights on their awareness and execution. Does their day-to-day understanding actually align with the documented policies? Then, observations, and this is huge for AI. This is where an auditor watches real-time processes, like seeing firsthand how an incident response team handles a simulated security breach. Finally, data analytics. Using advanced tools to detect anomalies or unauthorized access patterns in massive, complex log files that a human could never realistically read manually. You know, the reality is that a truly diligent auditor isn't just going to pick one method and call it a day. They have to employ multiple strategies to minimize risks and ensure the data they're working with is completely trustworthy. They mix and match these strategies to avoid bias, cut down on human error, and guarantee total reliability. If they only look at documents and never actually talk to the people operating the AI, they just aren't getting the full, verifiable picture.
This takes us to Section 4, shielding data from critical risks through mitigation. So we've gathered the data using our toolkit, but once we have it in hand, how do we know it hasn't been forged, tampered with, or corrupted? We have to protect this evidence with an impenetrable verification shield. Step 1 is implementing cross-verification, which we touched on earlier, like checking system logs against interview notes. Step 2 is leveraging data integrity checks. And Step 3 is conducting regular updates to ensure that data perfectly reflects the absolute latest vulnerabilities and system states.
Actually, I want to pause on Step 2 for a second, because this is where the technical magic happens. In an AI audit, you can't just cross your fingers and trust that a log file hasn't been altered. ISO 42001 compliance requires us to use audit trails, hash values, and digital signatures to mathematically confirm data authenticity. It proves, literally without a shadow of a doubt, that the data the auditor is looking at is exactly what the system generated: zero tampering.
And finally, Section 5, building trust through verifiable truth, the ultimate goal. We've gone through some highly technical steps, rigid filters, and robust extraction tools. But why are we putting ourselves through all this rigorous verification in the first place?
Because honestly, gathering verifiable evidence isn't just some administrative checkbox exercise. Successful audits drive 3 major outcomes. First, compliance is achieved. But more importantly, it ensures that critical risks like security vulnerabilities, operational failures, or data privacy breaches are actively mitigated. And when you have that undeniable, verifiable proof, that's when deep, unshakable stakeholder trust is built. Your users and the wider public know for a fact that your AI system isn't just a mysterious black box. It's a secure, responsibly governed tool.
So whether you're building AI systems, managing them, or prepping to audit them, you really have to ask yourself, is your AI's evidence strong enough to survive the verification shield? Can your data stand up to those rigorous tests of accuracy, consistency, and integrity? Because if not, it is definitely time to get your data out of the avalanche and into the funnel.